So in this lecture, I am going to explain how to prepare a part program for multiple turning cycle. The main aim of this session is to familiarize the students about multiple turning cycle, the instructional objectives. This session is mainly designed to able to demonstrate a comprehensive understanding of the process by accurately identifying and describing each stage involved, including the tool selection, workpiece setup, and the sequence of machining operations, how you can perform in the multiple turning cycle. Learning outcomes. At the end of the session, you should be able to articulate the key principles and concepts underlying the multiple turning cycle, the ability to select appropriate cutting tools, set up the workpiece, adjust machine parameters, and execute multiple turning operations effectively. So, multiple turning cycle is a technique used in CNC programming where multiple operations are performed in a single setup. It involves the use of various cutting tools and machining parameters to perform a series of turning operations on a workpiece. By combining multiple operations into a single cycle, significant time savings can be achieved, leading to increased productivity and efficiency. In the manufacturing of shaft components, multiple turning cycle can significantly streamline the production process. Operations such as facing, rough turning, finish turning, and chambering can be combined into a single cycle, resulting in reducing the setup time and improved productivity. So, by carefully planning the sequence of turning operations and implementing a well structured CNC program, manufacturers can optimize their production process and achieve higher productivity. So, syntax mainly used for multiple turning cycle is two blocks. First block is G71 UR and second block is G71 PQUWFS. Now let us see what is UR, PQ, etc. U is defined as a depth of cut. How much depth of cut that we can mention in the U, and R is the retract height. So after each pass, some amount of the tool is retract back. That amount we can mention here. R is the retract height, and P is the contour. So the multiple turning cycle contour beginning and ending, that block numbers we can mention here. P is the contour start block number and Q is the contour end block number. So in between these two block numbers, entire process is cycling. Next, the U is the finishing allowance in x-axis and W is the finishing allowance in z-axis. So these finishing allowance you can left over here, that is machined in the finishing cycle. This is the rough cycle and one more finishing cycle is also required to complete the operations. So F is the feed rate during the G71 cycle and S is the spindle speed during the G71 cycle. So this is the main syntax we are using for all multiple turning cycles. Now let us look at this diagram. Okay, I want to make the machining of the shape of this component like this. Okay. Now initially, if we assuming that this how many operations are involved here. Suppose you want to do the first you have to make the two-step turning. Here it is one step and this is the second step. After that you can make the taper turning here. Here it is the taper turning. So that means this entire machining you can also complete by step-by-step conventional part programming like step turning, taper turning. So two step turnings and two taper turnings required. Instead of that, you can use the one cycle to complete all the machining. This entire material is removed in the single cycle, that is this multiple turning cycle. Here it is illustrated in this diagram how the tool movement, the tool path is mentioned here. You can see that. Okay. Now let us assuming that the tool, this is the starting point of the tool. Okay. So and from this the tool will move. From this tool will move here. You can see the tool movement here is mentioned here. This is the line. The tool is moving this line up to this point. Okay. Then it will retract some amount, which amount is mentioned in the cycle, and again it come back. Again it will come back to this. Let me highlight the laser point so that you can easy to understand. Okay. So this is the path of the tool. Here retract and it will come back to here and again it will go to second one. Okay. So now it will come like this. It will see that it will come back. Now again it will go to the. So like this, the operations will be performed. This entire material is removed. Okay. Now you can see that this is the actual path of the component you want to machine. This is the final shape of the component. Okay. So with this final shape, here whatever amount is mentioned in the program, that finishing elements, that elements of the material is left over and remaining material is removed in this process. Okay. So this is during the rough cycle, entire the material is removed stepwise, step by step, step by step. All these operations can be taken by the same cycle. So that is why we mentioned the starting block number and ending block number. So between that, this process is going on continuously till the end of this point. So entire material is removed. Only the small amount of the material left over that is removed in the finishing cycle. This is the process actually taking place in the multiple turning cycle. Now let us see the program. So this is the code G21, G98 and G28 U0 W0. You can send the tool to the home portion and select the tool M06 T02 and set the spindle speed 1000 and rotating in clockwise direction. Then G00 X40 Z2. So tool will bring to the tool entry point. Then G71 U2 R1. This is the multiple turning cycle first block. And G71 B45Q. So 4560 is the block number, starting block number, finishing block number. And 0.5, 0.2 is the finishing elements left over in X direction and Z direction. Feed is 80. Then G01 Z minus 30. This is the starting block number. And X60 Z minus 60. And N55 Z minus 80. And 60 x 100 z minus 90. So this is the ending the block number. Okay. So after this, just go for the finishing cycle. So G70 again the same block numbers, the starting block number and finishing block number, and speed according to the finish you can change the spindle speed and feed. According to that, the machining is taking place. After completion of the finishing operation, then send tool to the home portion G28 U0 W0 and spindle stop. Program is end and rewind. So this is the simple the program we can write in the multiple turning cycle. So the same here, the first 4-5 blocks and last 4 blocks, 3 blocks are same, and middle one is just changes according to the shape of the component. Once you can practice, it's easy to write a part program for multiple turning cycle. Now let us see the self-assessment questions. What is the purpose of the M code in a multiple turning cycle? Here options are given. Now let's see that the right answer is to initiate tool changes. And second is which G code command is often used to initiate multiple turning cycle in a CNC program. The answer is G75. So the terminal questions. So these are the terminal questions we can prepare and can practice this multiple turning cycle, and these are the reference books. Okay. I hope everyone can understand how we can prepare multiple turning cycle for CNC part program. Thank you.